Electrical, instrumentation, and control engineering is the foundation of process automation and safety, especially in hazardous areas. As engineers working in environments governed by ATEX or EIC regulations, we face unique challenges that require both technical expertise and regulatory precision. One of the core issues we deal with is calibration and accuracy. Inaccurate sensors, whether due to drift, wear, or degradation, can lead to process deviations or safety loop failures. That's why traceable calibration and ongoing validation through zero checks, span tests, and loop verifications are critical, particularly in safety instrumented systems. Then there's the issue of noise and signal interference. EMI, ground loops, and crosstalk can wreak havoc on signal integrity. Whether we're using analog 420mm signals or digital protocols like Profibus or Modbus, robust shielding, correct grounding, and smart cable management are essential. Diagnostic tools help us identify and fix these issues before they lead to false readings or control instability. Integration is another major hurdle, especially at brownfield sites. New devices often need to interface with legacy PLCs, DCS systems, or SCADA platforms using different communication protocols. Functional testing alone isn't enough. Interoperability under dynamic conditions is where the real challenge lies. In hazardous zones, routine maintenance becomes far from routine. Restricted access, environmental wear, and the need for predictive diagnostics over reactive maintenance demand smarter strategies. Whether we're using self-diagnostics or historical trend analysis, effective fault isolation remains a key skill. And of course, safety and compliance drive everything we do. From EIC 61508 to ISO 13849, it's not just about ticking boxes at commissioning. We must maintain proof testing, zoning integrity, and lifecycle documentation throughout the plant's life. The tension between operational flexibility and safety conservatism is real, and navigating it requires judgment and alignment with stakeholders. Technological evolution brings promise, but also pressure. Smart sensors, wireless devices, and digital diagnostics require new skills and cybersecurity awareness. We must integrate these innovations without compromising certification or safety zone compliance. Lastly, no technical system is immune to human factors. Misconfigurations, misinterpretations, and miscommunications often cause more downtime than hardware failure. That's why cross-functional collaboration, clear documentation, and operator training are just as vital as the tools we deploy. In the end, excellence in EIC engineering isn't about eliminating every problem. It's about anticipating them, addressing them methodically, and ensuring plant safety and reliability under all conditions.